A RMB on a primary datum feature reference. Datum B, the primary datum feature shown, RMB is assumed because there aren't any modifying symbols on the datum boxes in the control frame. Datum axis B located by contacting unrelated AME around datum feature B. And it constrains 2 rotational and 2 translational degrees of freedom. Actual mating envelope, or AME. The cylinder reference primarily establishes the axis of unrelated actual mating envelope as the datum axis. It establishes the axis because not related to higher precedence datum feature. And cylinder reference secondary at RMB establishes the axis of related AME at the datum axis. And it establishes the axis because of the related tolerance to the higher precedence datum feature. Okay, RMB on a secondary or tertiary datum feature reference. References to datum features of size include applicable material boundary conditions, default RMB or specified MMB or LMB. And RMB requires that the simulation process contact the datum feature. Datum features of size contacted by related AME. And may only constrain degrees of freedom not already constrained by higher precedence datum features. MMB on primary datum feature references. When a shaft is the primary datum feature, the simulator size to the MMB must meet the 3 conditions for MMB to equal MMS of the feature, or maximum material size. The datum axis established at the center of the simulator or tool with a diameter equal to the shaft maximum material boundary size. And the simulator will not fully constrain rotational degrees of freedom relative to the simulated datum axis when the datum feature departs from maximum material boundary. Maximum material boundary on a secondary datum feature referenced. The secondary datum feature B referenced MMB in our example. The secondary datum simulator is perpendicular to datum A. The secondary datum axis is established by the simulator size to applicable maximum material boundary. It may move on secondary datum simulator when the secondary datum feature departs from maximum material boundary. MMB on a secondary and tertiary datum feature references the reference primary datum plane and the 2 features of size to establish the datum reference frame. MMC and perpendicularity to calculate applicable maximum material boundary to size. Secondary datum simulator if orientation tolerance is applied to the second datum feature. Maximum material condition and position tolerance to calculate applicable maximum material boundary size. Tertiary datum simulator if tertiary datum feature has position tolerance referencing primary and secondary datum features. Multiple feature control frames related to the same datum reference frame. ASME Y14.5 states position and profile tolerances may become one pattern of features when datum feature references are identical. simultaneous requirements, or the rule of simultaneity, sanity, I guess, and the maximum tolerance accumulation between features. Okay, datum targets based on order of precedence. Consider datum precedence when defining datum targets on a drawing. Identify the datum features on a given part because cast surfaces are too uneven for use as datum surfaces. And datum precedence for deciding the number of targets to show on the feature. Datum targets on dual precedence datum features. The primary datum feature in one tolerance specification, but secondary in another. Use appropriate number of targets for order of precedence. Identify using different letter for each datum. And multiple datum target symbols may be applied to one datum target. Notation to establish datum target constraints. Some tolerances require only primary datum feature reference. Example is perpendicular tolerance. Target locations must be constrained. Primary datum targets may not have well-defined location without the reference to secondary or tertiary datum features. Add drawing note that establishes how to find required targets. Common datum features. Two or more features used at the same time to establish one datum. The datum feature reference shows letters separated by a dash within one of the compartments. So in this example, we've got A-B. And it defines the runout using both those datums. The datum features of equal precedence and applicable to cylindrical, flat, and other features of shape. Features to establish an axis. Place the datum features in a chuck to find simulated datum axis. You may also place datum features in a V-block as a simulated datum. An example is a rotating shaft. Specifying common datum features permits design tolerances to reflect functional needs. Commonly supported by two or more bearings, and bearing surfaces establish shaft axis of rotation. Okay, a surface and two holes. Common to use two holes to locate a part during fabrication. Sometimes we actually have parts that have tooling holes in them specifically for that. And they can be identified as datum features and tolerances referenced to them. Using real features as datum features. Datum features are physical features on the part. Do not place a datum feature symbol on a center line. It's prohibited by the standard. It can cause confusion. And use method for one surface and two holes instead. Okay, stepped datum surfaces. You see this a lot in things that require datum targets, things like castings. So you can imagine that there's 3 points on this, and you have 3 tooling balls on a plate that are accurately placed to the drawing. And this part would rest on those 3 points, establishing a datum. And in this case, it's datum A. So target A1 through 3 are your 3 points to establish datum A. The condition of 2 or more non-coplanar surfaces establishing a single datum. A basic dimension defines the step distance for the datum feature simulator, and the profile tolerance defines the surface location tolerance is basic dimension that defines target step, distance, and distance between surfaces. Equalizing datum targets. Because workpiece, or it can cause the workpiece to be centered when the targets are contacted, and movable datum target symbol indicates the datum target simulator is movable. And the direction of movement is indicated with a line if needed. So in the example on the left, datum C has a line indicating that it can move. The size of the arc that meets the datum targets B1, C1, C2, and B2. So the movable part is only applicable to datum C. Okay, equalizing datum features can cause a workpiece to be centered when the features are contacted. Two surfaces may be used. Two perpendicular planes intersect at a vertex of angles between simulators, and one plane bisects an angle between two datum features. Okay, targets on a cylinders of 1 diameter. So a single datum feature letter is permitted for a datum target, point, line, or area with 1 or 2 cylinders of the same diameter. So in this case, it's the outside diameter of the part. And regardless, a material boundary requires the datum target simulator to move until contact is made with the part. Targets on cylinders with different diameters. Targets identified with different datum feature letters when datum axis defined by 2 cylinders of different diameters. The datum target points, lines, areas, or combination is established by the datum axis. And the same techniques are applied to external and internal features. Combined target areas and points. Datum's defined in a manner that best reflects the part functional requirements and facilitates manufacturing. Whatever combination accomplishes this is appropriate. Datum feature translation. It's possible to indicate in datum feature references that the datum feature simulator may be translated to another part or a fixture. So you're going to use the translation symbol, which is highlighted by the gray arrow in the GD&T callout we see here for a hole pattern. And it looks like the play button, sort of. And the simulator may translate. And the simulator size is not impacted by the tolerance relative to the higher precedence datum features. So in this case, datum C can be projected and doesn't necessarily control linear movement in that axis.